Who would have thought that just 120 light years away from us there would be a planet on which the first signs of life have now been found? Once again, we are dealing with an absolute masterpiece of the James Webb Space Telescope. This marvel of technology looked with its sharp eyes at a distant world and discovered the first signs of extraterrestrial life there. The exoplanet K2-18B has been shocking science since the first analyses. This planet is apparently a rich water world and could harbor far more life than our Earth. K2-18B is an exoplanet that has already secured its place in the history books of astronomy. Just over 120 light years from us, the planet orbits a red dwarf star, and K2-18b shows some significant signs of biological processes, making it one of the most sought-after objects of study today. James Webb was able to find 4 signatures of life forms in the planet's environment, and so far, this is considered an absolute exception. The sensational report now fuels many hopes of finally finding real life in the universe. Thanks to the perfect spectrometer analyses by James Webb, scientists were quickly able to see that this world plays a special role among exoplanets. When the analyses showed evidence of large amounts of water at the beginning of the study, the researchers were already alarmed, and what followed could change our science forever. For the first time, we are looking at a planet that can answer the questions of what life actually is and how it arises. Furthermore, this world could prove to us that the diversity of life in the universe is greater than we could previously have imagined. The questions of how many life forms there are in the universe and what they look like are not only of interest to scientists but also to many ordinary people. With the study of K2-18b, we may be on the verge of answering these questions for the first time. For biomarkers not only provide evidence of a world rich in water, but also, for the first time, serious evidence of the existence of extraterrestrial life in the environment of K2-18b. Evidence of methane and carbon dioxide was found, among other things. Both gases, especially when they occur together, are clear indications of organic processes and life. Dimethyl sulfide, DMS, was also detected, which is almost unequivocally considered proof of life. Probably few have heard of this gas, and on Earth, it's not really that spectacular. However, in the universe, it is. DMS is produced during the metabolism of algae and occurs in large quantities near seas, oceans, and large wetlands. You can already imagine that the discovery of DMS in the vicinity of a planet means nothing less than that there must be life in the oceans of this exoplanet. Algae are the simplest life forms on our planet, and they probably populated the primeval Earth oceans long before the first simple fish, snails, and mollusks appeared. However, algae were very likely the precursor to this life, and these plants may be one of the keys we need to understand the evolution of life. DMS on K2-18b can be seen as proof that there is at least algae in the world's oceans. Where there is algae, there can be further life. Despite its sensational nature, the find is currently still being treated with caution. Reputable scientists do not want to talk about finding the first aliens yet, although everything points to it. DMS, together with methane, carbon dioxide, and large amounts of water, are serious indications of the first habitable planet we have found in the universe. Let's take a closer look at the gas methane. If we consider how closely methane is associated with life, the prospects for life on K2-18b increase dramatically. Again, James Webb's precise spectrometer analyses showed a mixture of methane and carbon dioxide that speaks for a biologically active world. By way of comparison, Saturn's moon Titan, for example, also has large amounts of methane, but other biomarkers, such as water or oxygen, are missing. Titan is very likely uninhabited, where there are only some very simple methane-based bacteria. Whether or not oceans with warm water and algae must sooner or later produce higher life is one of the great secrets of the evolution of life, and that is precisely what we want to uncover. K2-18b and the exciting discovery of biosignatures in the planet's environment could be another important step toward understanding how life arises in the universe and how it spreads. On Earth, methane is mainly produced by microorganisms. Other important sources include the gastrointestinal tracts of ruminants and large rice paddies. Methanogenic microorganisms do not live in methane, but they produce it in the course of their metabolic processes. Together with DMS, the methane deposits on K2-18B indicate at least one thing: abundant plant life. On Earth, algae and some phytoplankton species produce large amounts of DMS, which can then be found in our planet's atmosphere. The dimethyl sulfoniopropanate is produced by decomposition processes in coastal ecosystems, and from there, it enters the atmosphere. What exactly does the surface of K2-18B look like? We can do a lot, but unfortunately, we are not yet able to look exactly at the surface of exoplanets. The James Webb Telescope uses its spectrometers to analyze light that distant planets absorb from their stars and then re-emit. The interactions create a special pattern of light in different wavelengths. Water and oceans reflect light differently than forests, mountains, or deserts. The Webb telescope can examine the light in the planet's environment for gases and thus find biomarkers such as methane and DMS. In the case of K2-18B, with our technology, we see a kind of light imprint of the planet, but we don't have an exact image of the surface. We see the vapors of the oceans, metabolic products of algae or single-celled organisms, and we may be able to scan the carbon dioxide exhaled by life forms that inhabit such a world. But we can't see these life forms, so unfortunately, we can't determine exactly what they look like. Data from the James Webb Space Telescope tells us that K2-18B is a large water world, about 8.6 times the size of our Earth, and shrouded in a thick hydrogen atmosphere. This planet is one of the so-called Hycean worlds, a class of planets that scientists have only recently found in the universe. The discovery of the Hycean worlds was quite a surprise because scientists previously assumed that water in the universe was rather rare. When this new category of planets emerged, it was almost as if gigantic cosmic flying water droplets had suddenly appeared before the eyes of researchers. Hycean worlds are even more covered by water than our Earth, and they are significantly larger than average rocky worlds. This makes this type of planet particularly exciting because where there is so much water, the probability of life is very, very high. These planets are also often a bit warmer than our Earth and could be something like large, warm greenhouses. If the planets are not too hot, they would provide optimal conditions for the emergence of rich life. Imagine ocean-covered superworlds with a wealth of life in their waters, like the most colorful reefs in our seas. We also cannot rule out the possibility that such a world could produce higher life forms bound to the water. Civilizations that inhabit water worlds could be bizarre, hybrid creatures made of fish and intelligent life forms. K2-18b may be the first sign of abundant life in the universe, and we can hope that our science fiction ideas of crazy aliens and colorful life forms will soon come true. We'll have to wait and see. At the moment, scientists are working on a new technology that will enable us to scan biomarkers and metabolic products on distant planets even better, and thus determine whether there are further similarities to life forms on our planet.